Okay, Ali here again today. I'm going to talk about a few things I've got to make today, or try and make. I've got to make a tool that will do this nut up. There it is. That's what it is. It's just a little nut that goes on the end of a Landrover main shaft, and I've got a little very quick sketch here how I'm going to do it. Basically, we make them like an end-to-end pair, which is like here. Oh, where is it now? I'm trying to get it on the picture. I'm going to do it back to front. It's here. This picture here is what we're actually going to make, and that's kind of what the tool ends up like this one here. But anyhow, so the first thing to do is I've got to turn some material down to about 1 5/8 diameter, and it starts off about 2.5, and it's 43/40, so it's a bit of a waste of good material, but it's the only material I've got, and to buy another piece is going to cost a lot more than just turn that piece down. So that's going to be one of the jobs today. That's all kind of for now sort of thing, and I'll show a bit of machining doing that. It's not going to be terribly exciting. There might be a little bit on the Hass to cut the teeth, but that's about all it'll be, and then there's a few other bits and pieces to go together with it to make the actual tool. So I'll gradually make a few videos of that so you can see that being made. Okay, that's it for now. Okay, this is a bit of 43/40 in here. It's too big, it's got to be turned down to 1 5/8. First thing you do on most turning operations, if you've got to drill a hole in something, do the drilling first, because that will always tend to move the work. If it's going to move the work, if it's going to be moved, it'll move during the drilling operation, because that puts the most, generally speaking, puts the most force on the work, and it will knock it off center. So experience tells most of us old engineers drill a hole first. So we'll drill a hole first. 1/2 inch hole, then it's going to be opened out to it's not quite 15/16 is what I want, but I've only got a 59/64 drill, so it'll be 59/64, which is near enough. Near enough for our purposes. It's only a clearance hole. So 1/2 inch drill. This is how I work it out. 50 feet per minute on high speed steel. 3 times 1/2 inch is 1.5. 1.5 into 12 goes 8. 8 times 50 is about 400 RPM. I know you can push it probably a little more than that. So I've got a speed on this lathe of 440. So that's what we'll try it out. Also, this being 43/40, we may find that that's a little bit fast for this. Really, we ought to cut this probably at about 30 feet per minute. Probably we ought to actually cut this down to, we'll try 280. See how we get on. If she screams at me, it's too fast. We'll see how we get on. Get the old converter going, and away we go. Sorry, I don't have an inverter here. It's a converter. It's a phase converter that I use to convert all the single phase to 3 phase for these machines. So let's see how we get on. Stick a bit of coolant on. This lovely coolant thing to work. somewhere near. Nice bit of run out there. Oh well, doesn't matter for these purposes. Now we need about a 2.5 inch deep hole. That's cutting okay. Okay, that's 2.5 inches. Well, this is an old drill that was given to me in a pile of old junk, and giving it a resharpen, and we need to run it at about 30 feet per minute. That's about an inch, so that's 3 inches, so that goes in 12 4 times, so 4 times 30 is 120. So drop it down there and see how we get on. Quite tough old material. I think I'm going to put a couple of flaps on this drill so it holds a bit better. It's all been messed about with over the years. I don't know whether you can see the wear. Yeah, you can just about see it there. That's the wear of that little bit of drilling that did to that drill. Anyway, I'll just go and re-grind it. This side is not critical at all. In fact, there's nothing terribly critical on this anyway, apart from the teeth on the CNC machine. 6/4 what I need. Now, we're going to have to bore it. How deep have we got to go? 375. Sometimes you get a problem with rubbing, you can actually lift the tool a little bit. Help cure that. Not boring. Nothing wrong with grub screws, but they're just cheap and they're not made very well. Things. Supposed to have a 7mm hole in the end, which is nearly 7mm. This is what I prefer. Get this to focus. These stronger, much bigger socket holder in the end. That's 10mm opposed to 7. Set the compound round at 45 now. Looking a bit dry. There's some oil. Oh, it's loose. Fast for that tool. So I'm now going to hard it off and do the other end. Okay, here we are at the old pass. We're going to set up for machining that part. I'm going to leave the little old 3-jaw chuck on here. Flower cutter. Okay, got some clamps. Clamp this little chuck on here. I've just noticed this is going to fall through here. We don't want it falling through there. So we have to probably figure out some kind of solution. So we'll get this bolted down, and then what we've got to do next basically is tell the machine where it is, because it hasn't got a clue. You can't see where it is. You've got to tell the software where this chuck is. So I'll get it tightened down. sure it's good and tight. You don't want it moving. Okay. Now, stop that piece falling through. We'll put a little parallel here. And it can sit on that. That's better. You can see what's going on there. That's pretty well there. We'll tell the machine that it is centralised with the part. Now we need to tell the machine where the top of the part is. It knows where it is this way, but it doesn't know where it is this way. So I'll take this tool out. Put this tool in. This is tool 1. This is your carousel here. You have 20 tools in there. So you've still got to drill it there. And that's tool 1. I'm going to tell it where the top of this job is. It should be right in the centre at the moment. I'm just going to check that by eye. What I call a sanity check. Yes, it looks dead on centre. Now I've got to tell it where the top of that is. Now this doesn't have to be super accurate, but in a couple of thou will do, because we're only going to cut some grooves in the top there. Until it just grabs the ship. Each click is 1/1000th of an inch. It's just got it there. So we'll tell the machine now that tool 1, that's where it is. set measure. Z is minus 11.886. And make sure 11.886 goes in the machine. Now what I do here is I want to test the software. I will tell it the part is actually 4 inches above that. So I'll go in here and I'll put 4.0. Set the feed rate to about 10%. There we go, let's make another one on the other end. There we go, I think. There we go. Okay, so I now have it to this stage, which is where we have a double-ended tool. Now I cut that in half and it makes 2, and that's how I do that. And just part it off, and then you've got to find an extension piece for a socket and so on. So that's that bit.